A negative 3 coulomb point charge has a displacement of 1I minus 2J plus 3K meters from a negative 6 coulomb point charge. Write an expression for the vector electric force felt by the 6 coulomb charge. Okay, so let's begin by drawing this out. We have a negative 3 coulomb charge, and we have a negative 6 coulomb charge. And the 3-point charge has a displacement of this coming from the negative 6 coulomb point charge. So coming from the negative 6 coulomb point charge, we have a displacement of 1I minus 2J plus 3K meters. Okay, now we want to find the vector electric force felt by the 6 coulomb charge, which means that this is the force. We want to find this force. Okay? Now, recall that the equation to find the electrical force is equal to Coulomb's constant, which is K sub E, times the absolute value of the 2 points multiplied with each other, which means that it would be, okay, let's name the first point big Q times second point charge little q over the magnitude of the vector squared. Okay, so because this is the magnitude, let me make a change to this equation. So usually magnitude is written like this, squared. Okay, multiply by r unit. So this would be the unit vector. Okay, now let's find the magnitude of r squared. So the magnitude of r is equal to the square root of the vector. So square root of the vector, which is 1, plus negative 2, we square all these, plus 3 squared. Okay, this is the magnitude. And to find the unit vector for r, it's going to be the regular vector over its magnitude. So unit vector of r is going to be the regular vector. But here's the thing. We want to find the vector electric force felt by the 6 coulomb charge, which it's this way. But this vector is going this way, which means when we use this to find this, we use this, but we switch the signs because the direction is on the opposite way. So you would have a negative 1I, positive 2J, and a negative 3K. Okay, and then as for the magnitude, it would be this. 1 squared plus negative 2 squared plus 3 squared. It will be the same. Okay? So, we have the magnitude. We have the unit vector. We need to find the magnitude squared. So, magnitude squared is just this squared, which means that you're going to square this, okay? And now, we can simplify this because we just have to find whatever this is, clean it up a little bit. 1 squared is 1, negative 2 squared is 4, and 3 squared is 9. So 1 plus 4 plus 9, 1 plus 4 is 5, 5 plus 9 is 14. So you have square root of 14 squared, which you know that the root and square cancels out. So you have equals 14, okay? Circle that. Now, we have here, we can simplify this to be equal to, this one stays the same, 2J plus 3K. However, we can simplify this. We know that this is equal to 14, so 14, okay? Circle that. And then we can rewrite this equation, plug what we know in. We know that F sub E is equal to Coulomb's constant. Big Q and little q multiplied with each other, which means we have 3 multiplied by 6. 3 multiplied by 6, let me just write it out so you don't get confused, over magnitude squared, which is 14, multiplied by this unit, okay? Unit vector, -1i plus 2j plus minus 3k over root of 14, okay? So this would be your answer, but we can simplify it a little bit because we can multiply this out. So you have the electrical force equal to 3 times 16, no, 3 times 6 is 18, so we have 18 KE over 14 multiplied by -1 plus 2j minus 3k over square root of 14. And unit will be in newtons, so this would be your answer.